Hi guys, Ben Hurley here, and in this lesson we'll be learning how to use those push button switches together in our Arduino projects. Now, we've already used them before in the electronics lesson. We wired up a button to break a circuit and to connect the circuit to turn a LED on and off, and that's quite simple. But there's a little bit more to it when we're using buttons with Arduino. So let's go ahead and have a look at our web lesson here. There's a button. I'm just going to jump straight down to this diagram, and it's going to look a little complicated, but let's just see if we can see what's going on here. The big red boxes that say MCU, that's microcontroller unit, that's the Arduino. This is just a diagram that I pulled off the internet, so we'll just keep going with it. So we've got our button, which is the labeled switch here in the diagrams. In both sides, they're connected up to the microcontroller, and you can see that there's plus 5 volts at the top, and that little triangle thingy down the bottom, that's ground. That's the symbol, the circuit diagram symbol for ground. Now this isn't all one diagram, these are two different options. We can wire up a button with either a pull-up resistor, or we can wire it with a pull-down resistor. Okay. Now the thing to remember is that Arduinos are very sensitive. They can sense whether, well, firstly, we know that we've used them to send as an output to send the electricity out to the LED. What we're going to be doing here is using them as an input. So we're going to be using them to detect whether there is a high 5 volts present on the pin or whether there is a low ground signal connected to the pin. And right, so that sensor to tell those whether it's high or low, that's very sensitive. If you just have the pin not connected to anything, just open like we had it in the original electronics circuit, then it will pick up all sorts of random errant weird static electricity signals from the air, and it will sort of go between on and off, and you'll get all sorts of wrong readings, and you won't know what's going on. What we have to do is we have to have the button and we have to have the pin always connected to either positive 5 volts or ground. Okay, it has to be connected at all times. So let's just have a look at what's going on with the pull-up resistor version of the circuit. Okay, so at the moment the switch is open. That means we're not pushing the button. The little connector inside the button is open. Those two sides are separate. So when the switch is disconnected, we're not doing anything with the ground. The ground is disconnected. So when the button's not pressed, we've got the positive 5 volts being connected straight up to the MCU, the Arduino. So when the button's not being pressed, it's registering that it's sensing high 5 volts. Okay, now what happens when we press the switch? Now when we press the switch, we close that connection and we open up a path down to ground, to ground or 0 volts or negative terminal on a battery. So what one's it going to decide on? We've got two connections. We've got positive up the top with the resistor, and we've got the grounds down the bottom. Now the whole point of that resistor is that the electricity always wants to follow the path of least resistance, right? So there is resistance going to the 5 volts at the top, and there's no resistance going down to ground down the bottom. So when the switch is pressed, it's going to prefer the signal to ground. It's going to have an easier path than the path with the resistor up to 5 volts. So when the switch is pressed, the pin is going to read ground or low or 0 volts. So that's how the pull-up resistor works. We have the pin always connected to 5 volts through a pull-up resistor, which pulls the pin up to 5 volts when the button's not being pressed. And then when the button's pressed, we get a direct connection to ground so that the pin reads ground when the button is pressed. So we get two different readings by pressing the switch. And if we go over to the other side with the pull-down resistor, that's exactly the same thing but opposite. So when the switch is not being pressed, we're always connected to ground through the pull-down resistor. We're being pulled down to ground at all times. Then when the switch is connected, we've got that direct path with no resistance going up to the 5 volts. So this is the opposite way. So when the switch is not pressed, we're reading low rather, and when the switch is pressed, we're reading high. Okay, it doesn't really matter which way around we go, because we can always flip around what we do, whether it's high or low, with our programming, with our coding, because we've got full control over whether we do something on a high or whether we do something on a low. Okay, so let's go down and have a look at our next step is to build this circuit. And we've got another fritzing diagram here. So as you can see, our diagram here is matching. This is actually the pull-up resistor version. So we'll just quickly go up and check our pull-up resistor diagram. Let's start with this junction in the middle. So the diagram with the pull-up resistor, we've got that junction in the middle where we've got the switch and the resistor both being connected to the digital pin on the Arduino. So let's have a look there. Yep, you can see that over on the left side of the button, we've got the junction with the switch and the resistor, and they're both connected up through that blue wire to pin number 2 we're using as our input pin, so that matches the diagram. What else have we got? The other side of the resistor is connected to 5 volts. Check that. Yep, the other side of the resistor to the button is connected through that red wire into the long red positive 5 volt rail on the breadboard, which is connected over to the 5 volt pin on the Arduino. And then lastly, on the other end of the switch, at the other end of the junction, the switch is connected to ground. So down here in our fritzing diagram, the other side of the switch is connected to the ground rail, the blue long rail, which is connected through the black wire over to ground. So let's go ahead and build that circuit, and then we'll talk some more and we'll learn about the coding that we need to make this project. So here we go. Let's connect up our button with a pull-up resistor. So I've already left behind all my LED wiring from the last lesson, because we'll need that, because we're going to be using the button to turn our LED off and on again. Okay, let's get our diagram up on the screen so we can make sure we follow all the wires. Okay, you can see I haven't included the LED wiring here, just the stuff for the button, just to make things a bit simpler and easier to follow. Now, I'm probably not going to end up exactly looking like this, but that's okay. We just need to follow the connections and make sure all the connections are in the right place. Okay, now down here you can see how I'm taking the 5 volts and the ground, and I'm making 5 volt and ground rails from these on these sections here with the blue and the red lines. So let's do that. I'll get rid of my LED ground wire, because I'm going to connect that into the ground rail that I'm going to create. So let's put the ground in that pin there to the ground rail instead, and I'll put the ground back to the LED because it needs to go around to ground, but I'll connect it up to our ground rail. There we go. Done. Now let's get a nice red wire. I always like to use red for positive voltage, and take our 5 volt pin and connect it up to our red rail over here. Now you notice how that the red and the blue lines stop in the middle here. That means they're not connected. So in order for our ground rail to work over on this side, we'll need to connect it up. So I'll just get a wire on that side and then connect it up to this side, and we're ready to go. So let's have a look at this diagram and follow all our connections. We've got this blue wire at the top here going from digital pin 2 around to the left hand side of the switch. So here we go, we've got a blue wire. Ooh. And we'll go from pin 2, and I'll take it across over to the left hand side of the switch. And then we need to get a resistor and put one side also to that same side of the switch, and then the other end to our positive rail. So I've got another 220 ohm resistor here. The value doesn't really matter, and it's a little bit busy over here. I'm actually going to tuck in there in that same side as the pin, the digital pin 2. I'm going to bring that over to the other side where I've got a bit more room. Like I said, it doesn't matter exactly where you put things as long as all the connections are the same. And we just need to connect up the other side of that resistor back to our positive rail. So I'll get a red one to go to the positive rail. Make myself some room there. Okay, and last thing left, we need a wire to take the other side of the button back to ground. So I might actually just remove this one for just a second, give myself some room. Taking the right hand side of the switch to the ground rail, and then I'll put my blue wire back on digital pin 2, and then I should be all done. Now it's a little bit messy, don't worry about that so much, because the next step I'm going to show you is how to do this a little bit neater and tidier. So we'll go back to the big view, and let's grab our trusty 9-volt battery, or you can plug it into the USB cord into your computer. I've already got the sketch loaded, so when I push this button, if I can reach it, here we go. Our LED lights up when I push the button, and when I let it go, it turns the LED off. Okay, so you might be thinking, oh great, we just did a very complicated version of that very simple circuit when we just hooked up an LED on the breadboard with a power supply and didn't even use the Arduino. And you'd be right, but that was the only way we could do it with just the electronic components. With the Arduino, we've got coding in there. We can flip the logic. We could make it the opposite way around. So we could make it so that the LED is always on and then turns it off when we press the button. Or we could make it blink 10 times when they press the button and do all sorts of customize things like that. So we've got a lot more power, a lot more freedom to do a lot more specialized operations. As long as we know the coding, we can make the LED do whatever we want. Okay, so now that we've built our button on our breadboard, let's go ahead and learn how to code it. So we'll go over to our coding view. Now I've just brought up the LED sketch we did in the last lesson. So the first thing I'm going to do is save it as something else. So I'm just going to quickly call it button like that. Now I've still got my LED program and I'm starting a new one. So now what we want to do is we want to do a pin mode to set up our button pin. So we'll go pin mode, and we're doing button pin number 2 for our button, and we're going to set that up as an input because we're sensing the electric signals coming in to the pin via the button. Okay, so our button is an input, and there we go. Now to tell what our button is doing, we need to have a way to test whether it's on or whether it's off. Okay, so let's just head back to our website for just a second. I've got a little thing here. I'll go back to digital reads in a second. We need to have a think about this if statement. So if we want to test whether something is one thing or the other, if we want to do something depending on something, we need to ask ourselves, if this is the case, then do something, or else, if that's not the case, then we're going to do something else. So that's what an if statement does. It tests a certain condition, tests to see whether something is true. So we start with the word if, and then in brackets we put down what condition we're testing, and then we have a curly brackets like we talked about with the void loop and the void setup. There, whatever code we put in between those curly brackets gets executed. In this case, if the condition is true, the code inside those first curly brackets gets executed, gets run, and then we have else. So that's for what to do if that condition is not true, if something else is true. So we have our curly brackets and we do those steps if that thing is not true. So let's go and start putting that into, our code. I'm going to get rid of, actually I might not get rid of that, I'll just pop it down a bit. So we'll start with if something, and we'll start our open curly brackets, and Arduino very handily puts the other side of the bracket in for us. So I'm going to just skip this step for now. I'm going to say if, so we're going to test for if the button is pressed, basically. What do we want to do? We want to turn our LED on, which we already have over here. Our digital write high equals turn the LED on, send the electricity down to the LED. So I'll stick that down in there, then enter. Else, what do I want to do if the button is not pressed? I want to turn the LED off. Okay, so I'll grab my turn the LED off digital write low statement down there, and I'll stick that inside. Now I don't need these delays anymore because I'm not blinking. I'm just turning the LED on and off depending on what's happening with the button. Okay, so now let's have a look at this condition. We need to say, what am I testing? What is the condition that means I want to turn on the LED? Well, I want the button to be pressed. Okay, now what is happening when the button is pressed? We need to go back to our diagram on the website, and we need to have a look at our circuit diagram. So we did a pull up resistor on the left. So when the button is not pressed, the pin is connected to 5 volts through the resistor. When the button is pressed, we're connected to ground. Okay, now ground means it's low, it's connected to ground. So just like when we write digital write low, that's connecting to ground. When we write digital write high, high means connected to 5 volts. So when we're pressing the button, we're connecting up to the ground, and we're going that route because it's the path of least resistance. So back to our coding view. So if, and we're going to do a digital read. So that's the opposite of a digital write. When we send out electricity, we're going to write to the pin. But when we want to read from the pin, we want to sense whether there's a high or a low. We do a digital read. And we're doing a digital read on pin 2, which is the button pin. And we don't need to do anything else. We just read what the value is. Okay, so if digital read on pin 2, so if the reading on the button equals low, just like that, okay, close bracket. Now this equals is very important. If you put 1 equals in, that is not testing a condition. That is assigning the value low to digital read. Okay, we don't want to do that. We don't want to say digital read is low. We want to find out if digital read is low. So we need a double equals. Whenever you're doing a if something equals something, it's always double equals. That's the most common mistake to make, and it's really hard to find if you have really weird things happening with your program. It's not behaving the way you want it to. First thing is to check all your if statements. If you're using equals in an if statement, make sure there are double equals. That's super important. So if the reading on pin 2, the button, is low, that means the button's pressed, then we're going to send the LED pin 13 high, that means turn it on. Else, that means opposite, if the digital read is not low, if it's high, it won't be low, then we're going to send the pin, the LED, we're going to turn the LED off and send that a low signal to turn that off. Okay, so that should be good to go. That's it. Let's have a look at our website here just to make sure that we've done everything nicely. Yep, if it's low, send it high, else send it low. Okay, now that seems a bit backwards. Wouldn't it make more sense if we did the other type of button, if we did the pull down resistor, then all of the lows and the highs would be backwards. That would probably make a little bit more sense. Let's go back to our diagram. If we did this pull down resistor on the right, then the button will be connected to high when pressed, straight up to the 5 volts, easier path than the resistor. And if it's not pressed, it will be low. If we did it that way, that would make the coding a little bit simpler. We would have, if the digital read is high, then put the LED high. Else, if it's low, put it low. And that would be a little bit more sensible, probably make more sense. But the reason we don't want to do that, right, is because we have a really cool feature on the Arduino. It actually has an inbuilt pull-up resistor inside the microchip on the board. So we don't actually have to do connect up external pull-up or pull-down resistor like we just did on our breadboard. We can actually do a much easier build. So now I'm going to show you how to hook up the button by using not using an external resistor. We're going to use the inbuilt pull-up resistor this time. So check that out, then we'll look at the code. So here we go. The hookup for a button using the Arduino's inbuilt pull-up resistors is it's a bit more straightforward. All you need to do is to I've started off with the LED part just the same as before, so that's all ready to go. All we need to do is to hook up one side of the button to our pin, input pin 2, digital pin 2, and then the other side to the ground rail. And then when we press the button, the digital pin gets connected up to the ground, which gives it a low reading, and the inbuilt pull-up resistor does the rest. So let's power up and give it a test. Turning on, I've changed the program to the pull-up with the input with the pull-up resistors. So, and it doesn't work. Let's see, what have I done wrong? I've got ground there. I've got my pin 13 there. That's what's wrong. I forgot to connect up the two ground rails across there. See that? Sneaky. So whenever you're using the whole ground rail, it's always a good idea to make sure that you jump them together. Sorry about the focus. Okay, so because I didn't have that wire across there, my ground wire from the Arduino was stopped here. It wasn't getting across to the button, so that when I pressed the button it wasn't connecting up to ground. So fingers crossed. There we go, it works now. So that's good. That was an example of troubleshooting, having a look at the wiring, making sure I didn't make any mistakes there. Okay, so that was pretty easy. Now let's have a look at what we have to do in the code to use the button with an inbuilt pull-up resistor. So we'll bring back our IDE, and all we have to do, it's so easy, where we have our pin mode for our button, pin mode pin 2 as an input, instead of just input we go underscore pull up, and we're done. And that tells Arduino to set up that pin with its inbuilt pull-up resistor so that it's always connected to 5 volts via its internal pull-up resistor. And then when we press the button the way we wired it, it just sends that direct path to the ground, which overrides the pull-up resistor with the path of least resistance. And then we'll have a reading of low when the button is pressed. So that's why we use the logic that way around, because we have inbuilt pull-up resistors inside Arduino's microcontroller. And that's something that you can find in all sorts of different microcontrollers, have inbuilt pull-up resistors, and it makes it a lot easier to hook things up. So give that a go, and that's how you use a button with Arduino. So in our next lesson, we're going to go take buttons another step further, and we're going to create a toggle switch. What that means is we'll have a button where we don't hold it to turn the LED off and it doesn't turn off when we let it go. We do a quick press and it stays on until we do another quick press and that turns the LED off. So we toggle it on with one press and toggle back off again with another press. That takes a little bit more coding and a little bit more logic, but pretty easy to do. So let's have a look at that next time. Catch you later. Bye.